Hello, welcome to Chingster's video on quadratic equations and discriminant. In this video, you will learn how to solve quadratic equations and look at the roots of the solution. Now let's look at example 1. Solve the following quadratic equations by factorization. So please pause the video and try this on your own and then check your answers with mine. So I will look at how you can factorize the expression on the left. So very quickly, I'm going to just write my two brackets in. The coefficient of x squared is 1, so it's easy. So the first term has to be x and x. And to look at how you can factorize this, I'll look at the factors of 40. So 40 is equals to 1 times 40, 2 times 20, 4 times 10, and 5 times 8. So which pair will give you a 3? So in this case, it will be 5 and 8. So I'll put 5 here and 8 here. And we want positive 3, and this is negative 40. So the two signs are opposite. So it's plus 8 and minus 5. So x is equals to, so a times b is equal to 0. So a is equal to 0 or b is equal to 0. So x is equal to negative 8 or 5. And for the second example, part B, so it's 2x and then x here is equal to 0. And again, I look at the factors of 2. 2 is 1 times 2, and 4 is equals to 1 times 4 and 2 times. We want to look at which factors will give you the coefficient of negative 7x for the middle term. So if you look at, say, 1 and 2, I get a 2, and then 2 and 2, I get 4. So 4 and 2 will not give you a 7, whether you add or subtract. So let's look at another combination. So I'm going to try, say, 2 and 4, that is 8, and then 1 and 1, which is 1. So 8 and 1, it is possible to give you a 7. So 2 has to multiply by 4, and 1 goes here. And this is negative 4, so we're looking at opposites. So, and we want a negative 7. So this is, we want negative 8x, so this is negative, and the plus here. And then when you multiply the other term, this is plus x, so you get a negative 7x. So the final answer will be x is equals to negative half or 4. Now let's look at example 3. Solve the following by completing the square. Give your answers in exact form. So when we complete the square to solve the quadratic equation, is slightly different from completing the square to change it from the general form to vertex form. So when solving an equation, what you want to do is to keep the x squared and the x term on the left-hand side. So in this case, I will subtract, I add 25 to both sides. So I end up with the x squared plus 5x equals to 25. And I want to add something here to make this a perfect square. So I want to make this x plus, it will be half of 5, so it's 5 over 2 squared. So in order to make this a perfect square, when you expand x plus 5 over 2 squared, okay, so this is the same as the formula x plus y squared. When you expand this, you end up with x squared plus 2x y plus y squared. So this becomes x squared plus 5x plus 25 over 4. So I will need to add 25 over 4 to both sides in order to keep the left-hand side a perfect square. So this becomes, and I get 25 over 4, right? And then this has to, I have to make it a 4 denominator. So my value here would be 4 times 25 is 100, so I get 125 over 4. So very nicely, I have a perfect square on the left-hand side. What I want to do now is to extract the roots from both sides. I will take the square root of both sides. And don't forget your positive and negative value. So your left-hand side becomes x plus 5 over 2 equals to positive negative of square root 125 over 4. We can apply the rules of square root of a over b is equals to square root of a over square root of b. So in this case, is x plus 5 over 2 equals to positive negative square root of 125 over 2. And 125 can be simplified as 25 times 5. So the value on the right hand side becomes, so equals to positive negative, square root of 25 is 5, and then root 5 over 2. So x is equals to negative 5 minus 5 root 5 over 2, or negative 5 plus 5 root 5 over 2. So this is the answer in exact form. Now try example B on your own and check your answers with mine. It is always easier to complete the square when the coefficient of x squared is equals to 1. So first I will divide the whole equation by 2. I end up with x squared minus 7 over 2x plus half is equals to 0. Then we'll do what we did in example 1. We will keep the x squared and the x term on the left hand side and subtract half to both sides. Now to make this a perfect square, don't forget to divide 7 over 2 by 2. So this is 7 over 4 squared. And when we expand this, we get this extra term of 7 over 4 squared. So we need to add 7 over 4 squared to both sides. And this becomes plus 49 over 16. And from here, when I simplify the right hand side, I'll need to multiply it by 8 by 8. And 49 minus 8, you get 41 over 16. And I will now extract the roots from both sides. Don't forget your positive and negative sign. So from here, so x is equals to 7 over 4 plus or minus square root of 41 over 16. So I can simplify the radicand. So it's 7 plus or minus square root 41 over 4. This is the answer in exact form. The quadratic formula. For a quadratic equation in a form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0, the solutions or roots are given by x is equals to negative b plus or minus square root of b squared minus 4ac all over 2a. In case you're wondering how we obtain the quadratic formula from the general equation, one way we can do here is by completing the square. I will show you how to do it here. So we have ax squared plus bx plus c is equal to 0. So remember, we want to solve the equation by completing the square. First, we will subtract c from both sides. And then I will divide the whole equation by a. And now, when I make it a perfect square, this becomes plus b, divide the coefficient of x by 2 square. And remember, when I expand the perfect square on the left-hand side, I'm going to end up with the extra term of b squared over 4a squared. So I need to add b squared over 4a squared to both sides. And I can now continue to simplify the right-hand side. I multiply this by 4a, so the right-hand side ends up with b squared minus 4ac over 4a squared. And now I will extract the roots from both sides to solve for x. So I end up with x plus b over 2a is equals to positive or negative square root of b squared minus 4ac over 4a squared. And if I apply the roots of square root of a over b is the same as square root of a divided by square root of b. So the right hand side, I'll end up with positive negative square root of b squared minus 4ac, the whole thing over square root of 4a squared, which is 2a. So now I'll end up with x is equals to negative b plus or minus square root of b squared minus 4ac over 2a, which is our quadratic formula. Now let's look at example 4. Use the quadratic formula to solve the following equations. Leave your answers in exact form. So let's look at part A. So we know that A is equals to 1, B is equals to 11, C is equals to 24. So for this, we will write x is equals to negative 11 plus or minus the square root of b squared, which is 121, minus 4 times 1 times 24 over 2. So it's negative 11 plus or minus the square root of 121 minus 4 times 24, which is equals to 96. So you have 121 minus 96 over 2, and that is negative 11 plus or minus. So 121 minus 96 is square root of 25 over 2. So you end up with negative 11 plus or minus 5 over 2. And negative 11 minus 5 is negative 16 divided by 2 will be negative 8. Negative 11 plus 5 will be negative 6 divided by 2. That will be negative 3. So the answer will be negative 8 or negative 3. For part B, x is equals to negative 8 plus or minus b squared, which is 8 squared is 64, minus 3 times 4 times 3 times 4 over 2 times 3, which is 6. So it's negative 8 plus or minus square root 64 minus 48, which is equals to 16 over 6. So you end up with negative 8 plus or minus 4 over 6, and that gives us negative 8 minus 4, which is minus 12, divided by 6 will be negative 2, or negative 8 plus 4, which is negative 4 over 6, so will be negative 2/3. For part C, I would like you to change your question to x squared minus 2x plus 1 is equals to 0. So now we apply the quadratic formula. So x is equals to 2 plus or minus square root of b squared, which is negative 2 times negative 2. Don't forget that the answer is positive, so it's 4 minus 4 times 1 times 3. This is over 2, and then this is from here you get 2 plus or minus 4 minus 4 is square root of 0 over 2. The answer is just 1. And for part D, x is equals to negative 1 plus or minus square root of 1, which is b squared minus 4 times 2 times 1 over 2 times 2. So you end up with negative 1 plus or minus 1 minus 8 is negative 7, so you get over 4. And for this case, we cannot simplify it further. We cannot take the square root of negative 7, so in this case, we will say no real roots or no real solution. We will be learning about imaginary numbers in this course, and then you will know that there's actually imaginary roots. Okay, so for now, let's look at what happens to the value underneath your square root symbol. We call it the b squared minus 4ac, the discriminant. When your discriminant is, say, 25 here, is positive, you realize that you'll see that we have two possible answers here, okay? When part B, we have square root of 16, you also have end up with two possible answers. And for part C, when your discriminant is 0, you have one answer here. And when your discriminant is negative, you get no real roots or no real solution. So what does this mean graphically? So for part A, we know that the solutions are -8 and -3. A is positive, so it has a minimum, so your graph actually looks like that. For part B, again, you have -2 and -2/3. This is also a minimum, and it goes like that. For part C, 1 is your solution, and this is A is positive, so again, it's looking this way. And for part D, is no solution, so your parabola is actually above your line, above your x-axis. So that's why there's no real roots or no real solution. So what happens here is that when your discriminant is greater than 0, you get two possible solutions here. Your parabola will cut the x-axis at two distinct points, and when it is equal to 0, the discriminant is equal to 0, you cut at one point, and when it is less than 0, when it's negative, it doesn't cut the x-axis. The discriminant, given a quadratic equation of the form ax squared plus bx plus c equals to 0, a and b and c are real numbers and a is not equal to 0, the discriminant is the expression in the formula that is under the square root and is denoted by the Greek symbol delta. So this is the delta, and delta is equals to b squared minus 4ac. So there are three cases here. So in case 1, when your discriminant is positive, then we know that x is equals to -b plus or minus square root of b squared minus 4ac over 2a, where there are two real distinct roots. When case 2, when your discriminant is equal to 0, then x is equals to -b over 2a. And this is regarded as one repeated real root. And the third situation, when case 3 here, when your discriminant is less than 0, then square root of b squared minus 4ac is not real. In this case, there is no real solution. Let's look at example 6. Without solving, determine the nature of the roots of each equation. So in this case, part A, we want to solve for the discriminant is equals to 7 squared minus 4 times 5 times -1. And this is 49 minus plus 20, you get 69, and this is greater than 0. So we say that there are two distinct real roots. For part B, 25, x squared plus 49 equals to -70. Don't forget to rearrange it to get the general form. So minus 70x plus 49 is equals to 0. So the discriminant is equals to -70 squared minus 4 times 25 times 49 here. This is equal to 4900 minus 4900, and you get 0. So I can say that there is one repeated real root. For part C, we have 2x squared plus 7 over 4x plus half. So the discriminant is equals to 7 over 4 squared minus 4 times 2 times half. So you end up with 49 over 16 minus 4, which is 49 over 16 minus 64 over 16, and this is negative 15 over 16, which is less than 0. So in this case, I would say that it has got no real roots. We have reached the end of this video. Thank you for watching, and goodbye.